In this video, we're going to talk about an algorithm for processing arrays. We're going to be looking at several common algorithms that are used on lists of items, which we might store in an array in our Java program. One example of a common array algorithm is searching through the array to find a specific value. We're going to look at two different search algorithms. The first is called sequential search or linear search. Searching through an array is the process of determining if a specific value appears in an array. Using the sequential search algorithm, the idea is to create a key or value that you're searching for in the collection. Then iterate through the entire array, moving from left to right. As you iterate through the array, you want to compare each of the actual array elements to the key value. If they match, that means you've located the item. If you finish iterating through the array, then you haven't located the item, and the item doesn't appear in the array. Let's look at an animation to help us understand the process. I'm using a website that animates the common array algorithms so that you can see them visually. Whenever you're performing a sequential search or linear search, you want to enter a key value. That's the value that you're looking for. Let's say that in this collection of numbers, I'm looking for the number 96. I'm going to enter that as my key. You can see that we've created a set list of 5 values. That's the collection that we're looking through to see, is the value 96 in the collection? Using this tool, you can reset the animation, and you can also provide custom input or change the size of the list so that you can see how the algorithm operates with different data. I'm just going to go with the standard data that they pre-generated for me. And again, I'm looking for the number 96. In the sequential search algorithm, you start with the first value in the list and you check to see, is that value equal to the key that I'm looking for? In this case, that means, is 67 equal to 96? It's not, so that means we should continue searching. Next, we'll compare the second value, that's the 69, to see if it's equal to 96. It is not. Then we'll move to the next item in the collection. In this case, we're looking to see, is 96 equal to 96? It sure is, so that means we've located our key within the collection. Once we find the key, the search can finish because we know that the value is in the collection. Let's try to look for a different value. Suppose I'm looking for the number 9 in this new array that's been generated. Again, the sequential search algorithm always starts searching with the value at position 0. So we're going to compare the value at position 0 in our array to the 9. They are not a match. Then we'll compare to the item at position 1. Not a match. Then we'll compare to the item at position 2. That's not a match. Then we'll compare to the item at position 3. That's not a match. And finally, we'll look at the last element in the collection. The item at position 4 is also not a match for our key. Because we've reached the end of the collection, that means we have successfully searched through the array and determined that the key value 9 is not part of this list. Sometimes the sequential search algorithm is written to return a true-false value, indicating that the item was or wasn't located in the array. Other times you might write sequential search so that it remembers the position of the item that was found. In other words, it remembers the array index where that particular key is located within the collection. It's traditional for the sequential search algorithm to return a value of -1 if the item's not contained within the collection. We're going to write a sequential search algorithm using what we know to iterate through an array using a loop. In your notes, I provided some starter code. This code doesn't have anything to do with sequential search. It's just setting up the data in our program so that we have an array created. So you can see I'm making a scanner. I'm declaring a new list of integers. That's my array. In my program, I'm allocating it to have 10 spaces included in the collection. I set the length equal to 10. Then I prompt the user to enter 10 values. And I'm using a count controlled for loop to request that the user enter all of those values, just reading them in with the scanner, and then I'm assigning them to the individual elements in the array. Next up, I'm printing out the array just so that we can feel confident that the array values are stored correctly in the list. At that point, I'm ready to start writing my sequential search algorithm, and I have a little bit of code in here where I'm asking the user to enter the key value and reading that from standard input. I'm going to continue with the same example, but I'm going to write it in IntelliJ so that you can follow along with the code as we develop it. So again, I've included that same code that we were just talking through in IntelliJ, where I have the array declared. I read in the data from standard input so that I can create the array, and then I printed out the array. Finally, I started the sequential search algorithm by asking the user to enter their key value, and I read the key value in from input. So far, I haven't written the sequential search algorithm, but let's just run the program so far to see its operation. So I'm going to enter 10 numbers. You can enter them in any order. And then enter a key value. I'm going to enter 5. And again, our program doesn't do the search yet. We didn't write that. We've just written the input process and prompted the user to enter their key value. Next, let's add the loops that we could use to search through the array. Remember that the search process iterates through the array, so it searches through the collection one element at a time. So I'm going to write a count-controlled loop. I'm going to choose a while loop because we know that sometimes we won't iterate through the entire collection. Sometimes we need to look through the whole list of the array because the item isn't in the array, and it requires us to look through the entire collection before we can definitively say the key value is not in this collection. Other times the key value is in the collection, and when that happens, we don't need to continue processing elements to the right of that found item in the collection. We can immediately stop when we find the element. So because we won't always have to look through the entire array, I'm not going to use a for loop. I'm going to write my while loop. And I need to think about what causes me to stop iterating through the collection. So I want to think about when I want to keep searching through the collection. I want to keep searching through the collection if there are more items for me to consider. So in other words, if I haven't reached the end of the collection and determined that the key is not in there. So if I haven't reached the end yet, that means that the count is less than the length of the list. I want to keep going in that case. And then I also want to keep going if it's also true that I haven't already found the item. So if the key value is not the same as the value in the collection that I'm currently looking at, list at index count. And when we keep going, all we're doing is increasing the value of count so that we can move to the next item in the collection. After we've iterated through all of the elements and one of these two conditions has made our loop condition false, then we're ready to determine our outcome. So if the count is equal to the list.length, that means we went through the whole collection and the item was not found. We reached the end of the list without locating the key. The other possibility is that we ended the loop because the key is equal to the list at position count. In that case, we can print out a success message. We located the item. And those are really the only two things that can happen that would cause this loop to end. We could certainly have another else in here, but it should never get triggered. I'm going to print this dot. All right, let's run our sequential search algorithm. I'm going to enter 10 numbers 1, 2, 3, 4, 7, 8, 9, 0, 2. I think that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Super. So I'm going to search for a key value that is in the collection. Let's look for the number 3. It tells me number 3 is in the list, and we can see that it is right there when we print it out. Let's run our program again, and we'll try something that's not in the list and make sure that we get a good answer in that case as well. 1, 2, 3, 4, 5, 7, 8, 9, 0, 1. I think that's 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And then suppose I'm looking for a 6. 6 is not part of the collection. And our algorithm tells us that the key 6 is not found. So again, we've written our sequential search algorithm. This is it, this loop right here. The goal of the sequential search algorithm is to search through a collection looking for a particular value, just like we saw in the animation. It always starts at the beginning of the collection, compares each item to the key value. And if you haven't located the item, then you just increase the value of your index so that you can move to the next element in the collection. And you stop when either you have located the item or when you've exhausted the entire collection and determined that the value is not part of that list.